Okay, welcome to software testing. This is the lecture on test generation from requirements and code. Let's start with checking if you can hear me. Cannot see me right now. Now you can see me, but can you hear me? Great. Okay. So the subtitle of this lecture is From Requirements and From Code. So we're going to start from requirements, but really this are the contents. I'm going to start with just a short note on assignment 1 part 2, which is examined this week, oral examinations for that. And then we're going to do the lecture content, test case generations and some things there. And then in the end, we're going to talk about assignment 2 and assignment 3. So let's start on assignment 1, part 2 examination this week. So those of you who are doing this examination with me, that is, have signed up on the left-hand side of the booking schedule for online or Kalmar examination, then if you sit here or online, then you need a headset. You need to set up sound in Slack before our meeting and check that it works. Preferably a webcam also. I like to see you at least in the beginning, and then you're going to share your screen. But I think it's a good thing if you can see me and I can see you in the beginning. You might also want your driver's license or some ID to show me. Okay, I also want you to have your program environment started, and so that you can show your code and you can compile your code and you can run the tests so that everything goes smoothly. And check or read the different things that we might ask about. There should be a description under the assignment on things that we could ask you. So be prepared to be asked those things and the study questions. And it is okay to have some kind of notes to read from. Some people are getting really nervous when it comes to these oral examinations. I'm not here to hurt you in any way. So if that's the case, it's okay to tell me that you're nervous. And hopefully we can proceed with this examination anyway. Okay. So this is an old slide. Hopefully you remember that this is a test case and the different parts that a test case consists of. So first, a test case must have something to test, the system under test. So in this case, we have a max method that takes two arguments, x and y. And that is what we intend to test. We need something to test. And this applies for manual tests of a software also. In order to test something manually, you need a running software. Probably, right? Unless you're testing something statically. But for all dynamic tests, you need a running software. So for assignment 2, you need to get this web server up and running. Perhaps you're testing the console UI, or perhaps you're testing the actual web server, but you need to have the software up and running. So you need to compile it, you need to run it, and you need to know what arguments you need to send it in order to do that. So one, system under test. And a test case should describe how you get this. So perhaps it says that a prerequisite for testing this web server is that we have it running in the beginning, or that we should have it available and it's in some folder perhaps, or something like that. The second part is that we need test input. I frequently call this test data. You need some kind of values or some kind of input that you do to exercise the system under test. In this case, we have x3 and y4. These are the test data, and we specified the test data in the test case. A very common mistake in this course is to not provide test data. You say something like, add two numbers or something like that. But you should provide the exact test data. And the reason for this is that we want our test to be not flaky. Flaky tests were tests that, depending on the time and different things, you get different test results for the same system under test. And you don't want that, because then we don't know. So if we don't specify test data, you can get flaky tests. Sometimes they work, sometimes the tests succeed, sometimes the tests fail because we use different test data, and we don't want that. So we specify the test input in the test case. The test input doesn't need to be numbers like this. It could be mouse clicks. It could be that you input things, strings or something like that into a form. It could be that you click a button. It could be a succession of clicks. So first I click this, and then I click this, and then I do this. So the different things that need to happen for us to observe something. Then the third point is that we need something in a test case called expected output. This is the correct behavior of the thing that we're testing. And you've written unit tests, so you probably know that the expected output in those, and that is what I assert later on, right? But the same thing goes for any test case. After we've inputted whatever we input, what should be the output? What is the expected output? If we know the expected output, then we can do our work as oracles in order to get a test result. So then, from exercising the system under test, that was either running the method in a unit test, right? Or we do the manual steps, we input things, we click buttons and stuff like that. Then we get an actual output. That is what the system produces. And in this case, the expected output was that we get a 4, because that is the maximum number of 3 and 4. But the actual output is a 3. That is incorrect, right? Right? And so we get the actual output, and that is sort of the behavior you can see on the screen, or whatever means you have to observe this. From the actual output, then we get an observed output. It could be the same. It could be different things. It could be that the way of observation hides some aspects of this. It could be that it's actually outputting the correct thing on the screen, but we cannot really observe it for color reasons, or for whatever reason. It's too small, I cannot really see it, but it's actually correct, but we cannot see it. I would say probably that is failure due to not being able to see the output, but yeah. So we get an observed behavior, and then we make a judgment. And we, as oracles, compare the expected output with the observed behavior, and then we think, okay, is this correct or not? In the case of automated unit testing, we have an assert statement for this. And the assert statement says that, okay, this one failed and this one succeeded. Okay. You remember this, right? You've done this at least in automated unit tests. But this is going to be a bit more important to have all these things when you're doing manual testing. And from my experience is the test input, test data, specify it. If it's a form, a web form or something like that we're filling in, you actually write in the test case, this field is going to have this value. Perhaps you even do a screenshot of it and put it in the test case so it becomes very, very clear. Okay, so let's have some requirements, and let's look at some test cases for these requirements. So, and like this. So this is a requirement specification. In this case, it is a simple login system, so it has a form for a username and for a password. It also has some checkbox and a button where you can log in. So you're supposed to write a username here, a password here, and then we have this. But let's take a look at the requirement specification to start with. The requirement specification could look like this, could look like other things. There are different ways of writing these, but this one has something called a supplementary specification, and then it has use cases, and these use cases are a couple of use cases. So there are 4 use cases, and you've seen and you have written use cases before. But it also has a supplementary specification, and there are different like listings of requirements here. Typically, things in the supplementary specification are things that don't fit into a use case, or perhaps they are valid for all use cases. So we write them in a supplementary specification to not repeat ourselves. So in this case, the supplementary specification has things like the system should respond to input in an acceptable time frame. And for assignment 2, you should take a look if there are requirements like this, and I think there is. And you write tests for these also. So you cover these tests with test cases. So the system should be responsible, should respond to input in an acceptable time frame, requires some kind of test where we measure time. Or we have some oracle that experiences usage of this application so that we can do this. It could be here, and you see acceptable time frame. There's like a missing. It's not exact, right? And requirements can be like this because acceptable time frame depends on who is using the system and who is supposed to use the system. And in your case, in assignment 2, you need to fill in the gaps, right? So you need to read this scenario and think, okay, what is the acceptable time frame here? And is this acceptable time frame valid for, in assignment 2, you're starting the web server, right? So starting a web server could take like 20 seconds for me, and I would consider that acceptable time frame because I'm just starting it and then it runs, and then it should run for weeks, right? But when I load a web page, if I access the web server and I load a web page, I don't want to wait 20 seconds for a page. Then I want it to be really quick. Then I could like say that more than 1 second is not acceptable. Something like that. But I mean, if I access this web page, if it's a big web page, and I access it on a poor mobile connection, then 1 second is suddenly acceptable, right? So think about these things when you're doing when you're testing, when you're generating tests for these requirements. User friendliness is more or less that you need to think about, okay, how are things user friendly? Who is the expert on this? How can we test this? There are, to my knowledge, I'm not an interface tester guy, really. To my knowledge, there are like checklists that we can look at on user friendliness and stuff like that. But perhaps you can find, like, look up into this, or you just do. This requirement is covered during the exploratory testing, something like that. Or you generate manual test cases and say that you should, in every output that you get, you should be able to understand that output. And let's say in assignment 2, I'm very much hinting here, right? But in assignment 2, you don't always get user-friendly output. You get exceptions thrown at you when you do stuff. Helpful error messages, yeah. System avoids unnecessary input and stuff like that. So you should look at all of these, think, okay, what can I cover with test cases? Can I come up with something? And if you cannot come up with a test for this, then let's discuss this on Slack in the open channel, not to me, but in the open channel, because I think that other students are probably having the same kind of confusion or question. And then let's come up with something that is reasonable on Slack, and let's decide that that is the truth, right? There are also security considerations. I think these are also valid for your assignment too. Yeah. Could be other considerations here. The system should be written only in PHP. This because this is an assignment in PHP. So then, in order to test that requirement, we need to inspect the repository where we get the code, right? And see, is there any server-side JavaScript? Is there any whatever, anything else than PHP? Then it becomes a static test. Okay, probably also some exploratory testing is good for this one. Then we have the use cases, and in this case we have authenticate user, and that is a test case where we try to log into the system. We try to get authenticated. And the main scenario is specified first. It starts when a user wants to authenticate, system asks for a username, password, and if the system should save the user credentials. So let's take a look at this one. We want to log in, so we access this page. It's asked for a username or password and something that keeps me logged in. So this one, it seems that it does this already, right? And then the first sort of input, except from navigating to this page, which is probably a good thing to specify also that you should navigate to this page. A login form is sometimes behind some button click or something like that. I need to press login in the top rightmost corner of the screen to be able to access that. But here is the specify. Username provides username and password. So it's like something like that and something like that. And then it really doesn't say click on any button because use cases are not on that level. Use cases are a communication, so to speak, between the system and the users or the stakeholders. So, and a use case normally doesn't specify user interfaces and stuff like that. So it just says that the user provides username and password, but a test case specifies at least some of the things. So the test case for this needs to specify that the username goes into this part of the form, and the password goes here, so that we don't mix these up and put the wrong thing in the wrong box, because we want the test to be not flaky. If one tester puts the username in the password box and the password in the username box, they will get a different result from the one that puts it in the right ones, perhaps. Yeah. And the test case probably should specify that I should press login also. These were the test input. The test case should specify the exact test input, and in this case I think it should be admin or something like that. And the password is probably password. Something like that. And then welcome. Fantastic. No, we don't need to save that one. Okay. This was step 4. System authenticates the user and presents that authentication succeeded. Then, in order to test that, we need to observe. We need to have some expected output. So we generate an expected output, and then we compare that with the actual output. And this is the actual output because I'm running the system here. So let's take a look at the test case. And I've actually, in order to do this main success scenario, I have first a test case which is navigate to the page. And it says stuff about just the thing of loading the page. And normal navigation to page and page is shown is the sort of the thing that we need. And we also say something about the date, because there is a date down here. And the input is that we should clear all existing cookies. before we do this. So actually I need to log out here, and I need to inspect this, and I need to check my cookies, and then I need to go to that page and clear those. And then I can navigate to the page. In this case, I'm not logged in. I know how the system works. I don't have these cookies. So and then I navigate to the page. OK. In this case, I don't provide a link here. But if this was a system and we had a test server that is always running with the latest version, whatever, then we could have a link here in the test case to make this simple for the tester who is supposed to do this. So the tester doesn't need to go to you and ask, where is the link to the test system? OK. The text not logged in is shown. Not logged in. Yeah, that is shown. A form for login is shown. Yeah, this seems to be a form. Doesn't really specify much. Today's date and time is shown in the correct format. OK, the date and time, Monday, 3rd of December. Time is 13:38:08. And then I have a screenshot here. Oh, sorry. That specifies this also. And I think screenshots are pretty good for manual test cases because we take in this image very fast. But it turns out that some students who have conducted testing on my system read the date down there and saw that, oh, it's August 2015. So the test output here, which was 2018, must be wrong. But it actually, it's sort of over interpreting the test case expected output, right? Or just being funny. So let's go down. I have a lot of failed test cases. I prefer to write those before the... Here we have test case 1.7, successful login with correct username and password. So here we see that in order to start that test case, we need to run another test case before, because these are chained tests. And since I don't want to navigate to page here, I just write test case 1.1 as input. You could do this in different ways, but what I want you to notice here is that I want to avoid duplicated writing, really. So I got some question in Slack, and I'm just going to check that. So I get a question that, does that mean in assignment 2 we need an online server? In assignment 2, you don't really need an online server, but you could have an online server. Yes? I'm a bit vague. It's up to the groups to decide this. OK. So in order to avoid duplication, I put another test case input here. And that was navigate to page. We really don't need to check the output in that test case, when we run this test case. But we really want to navigate to the page first, writing in the URL, clearing out the cookies. That was the things that we need in this other order. Clearing out the cookies and then navigate. Then we enter password, and let username be admin. And then we press the login button. You can see that these are the test data, and this is also test data that I press a button. If there are multiple buttons, we should specify the exact button to press. And then we have the expected output, and that is the text login is shown, the feedback welcome is shown, a button for logout is shown, and there should be no login form. So let's do that again. Admin, password, login is shown, welcome is shown, a logout button is shown, there's no login form. Just to make it very clear, I added a screenshot. Adding a screenshot to the manual test cases are good, but we're going to talk about a good test suite later on, and things change. Requirements change. CSS scripts change, so the look of the output changes, and suddenly all these screenshots need to be replaced. so that the manual testers feel that they're actually working with the same product, and suddenly this becomes a backpack. So it was a good thing for me because I want my students to be able to test these things. If I were doing this, then I probably wanted this automatically generated or something like that. Okay, I think you get my drift. And let's see if I can find this one again. Okay. You remember that last lecture we talked about scenarios. And we have now stepped through the scenario which was the main success scenario, which was 1, 2, 3, 4 in this graph. But there are other alternative scenarios also that also needed testing. And in my case, I had test cases 1.2 to 1.7, which are these alternative ways, I think, at least one of these. And there are several of these, and it's because I want to provide helpful feedback, and I want to say exactly what the problem with the input was, and not just something was wrong with your username and password. I wanted to say that you missed inputting a username to begin with. So the alternate scenarios was that if the user wants the system to keep the user credentials for the easier login, and that is 3A, so we have an alternate path, 3A. And we also have user could not be authenticated, and that was 4A. And we might want to have some kind of path coverage or loop coverage on our user on our use case in order to think that we've covered this use case. So I would say that at least all the white arrows should be covered once. But you could also consider that perhaps we want to go 1, 2, 3, 4A, 2, 3, 4, or something like that. Or perhaps we go 1, 2, 3, 4A, 2, 3, 4A, 2, 3, 4, just to have that loop coverage. So we go through the loop 2 times. We could also have like 1, 2, 3, 4A, 2, 3A, 4A, 2, 3, 4, or something like that. It doesn't have to stop on 4. It could stop somewhere in this loop. But you understand that in order to fully cover this use case, we need to write more than one test case. And these are the test cases that I decided on. Navigate to page, we had failed login without any entered fields, failed login with only username, failed login with only password, failed login with wrong password but existing username, failed login with existing password but wrong username, so that we don't only check password for any of our users or something like that. Successful login with correct username and password. And then I have another test case 1.8, still login after reload, so that it's just not only output, that we're actually changed the state of our login and stuff like that. But I mean, these don't cover all the scenarios. I don't have first do a failed login and then a successful. That could be another test case. And first do a failed login with existing username, but wrong password, and then do a existing username and right password or something like that. I mean, there are different ways through this. So in assignment 2, you need to look at the use cases, and you need to think about this. Okay, what should I create? What kind of scenarios do I imagine? Perhaps draw this. And drawing this could be a good thing because you want other students who read your reports to think that you did a good job. So look at this, drawing this, but for the use cases that are given for the web server. Okay, do you remember this one? Also given you this one before, but you just want to step back so that we have some kind of need. Users in our system has a need to authenticate themselves. And then we have an authentication system, which is a feature. And that consists of 4 different use cases. And then from these use cases, we derive scenarios, a number of scenarios. But we also had the supplementary specification, which also generated test cases. And perhaps you have other test cases that you add that you just think of, that are perhaps not connected to these things, but connected to other things. It could be anything really. Perhaps you're adding stuff up here from the scenario. From the scenario, because the scenario is something like you need to look and see if the requirements works as specified. That was one part. But you also had a scenario in assignment 2 that we need to use this in an Internet of Things application thing. So perhaps you need to derive your own features in order to do this, to do good in this. So perhaps, does this work on whatever platform or something like that? Okay. Think of it as this. There is a bit of freedom in this assignment, and use it to do fun stuff and reasonable stuff. And I shown you this one last lecture also, right? So don't forget about showing traceability. And what I wanted you to see here is that these use cases have numbers on them. So in this case, use cases are called 1.1, 1.2, because those with a 1 probably belongs together in some way, or they are perhaps scenarios of the first use case. And the use case number 2 have a different number of scenarios and stuff like that. So I would say that use case is a number, and scenario is a number, and perhaps you want to have something. These are the supplementary specification in this case. This is just stolen from Wikipedia, so they are not using the same thing as I do in my requirements. These are technical requirements, so you can have some letters and some numbers and some dots, so that people can see that this use case or this test case failed, and that means that this use case don't work fully, and that means that this feature don't work fully, and that means that this need is not fully working. So you can by having some kind of traceability in numbering and stuff like that, then you can come up with a conclusion in the end. Because I want that in your test report, you should come up with a conclusion, an answer to the question: is this legacy system in assignment 2, is it any good for this scenario? And I guess you can come up with yes, and I guess you can come up with no. But you need to motivate these, right? By the testing that you have done, right? Sounds fun? So I think it's a good thing to discuss this in the group and think that, okay, we got this test case that failed. Does that mean that we recommend this system to be used in this scenario? And then you motivate. Okay. Perhaps. Yeah. Let's take a couple of more minutes. In the end, we will come up with a large number of tests. And you should probably remember the word exhaustive testing. And that was trying all alternatives, all possible inputs, and do them. And just in the super simple authentication system that I've shown you, there are too many inputs to do that. If I start now, I'm not going to finish in my lifetime, even if I write a script that does it. So we need to do something smarter. And this is the test selection problem. Select a subset of the test so that we reveal all errors in the program. And in order to do that, we need to step back again and look at a slide from the first lecture, where I just removed verification to not confuse you too much. The goal of testing was to uncover errors and build confidence in the software. So, if we have that goal, what is the ideal, the best test suite? So in order to find all errors in the program, we need to run all of the program, right? Perhaps not all paths, perhaps not loop coverage, but we need to at least run every line of code ever written. Unless that code is unreachable code. And quite common, and perhaps some of you remember that I said that if you have unreachable code, that could be code that you cannot test. Because it was, yeah. So unreachable code, I see a question mark in the audience. Unreachable code could, for instance, be that you have an if statement that no, I shouldn't use the word test, but checks that some input is larger than or something like that. And then if we step into that, then we have sort of the same if statement once again for some reason. And then the alternative path of that if statement is unreachable because we cannot first have x larger than 5 and then have x smaller than 5 unless x is changed, right? So it's pretty easy to create unreachable code. And if you connect a lot of different components, then it's quite common to have duplicated code and duplicated if statements, things, at least to my experience. Perhaps you never will write that kind of code, but I have done it. OK, so we need to cover the code in order to do that. So coverage, I would say coverage of the test or the requirements, and also coverage of the application code running. So a good test suite also finds the bugs if there are bugs. So we need to run the code with such an input so that we can detect or observe an output that is not correct. Also from lecture 1, right? And then I just ordered these for the stairs. But then it's quite good if we want to run this test suite again. Because doing things, especially manual, is painful. And when I have conducted manual testing of the login system over and over and over again for day out and day in, then I'm going to be very, very tired of doing it. And I'm going to miss details, and I'm not going to observe the actual output. I'm just going to observe what I expect to be there and do stupid mistakes. Because regression testing, which is testing things again after doing a change, is painful. Which means that a good ideal test suite is we can automate that. We could use tools like Selenium. We could use tools like JMeter in order to automate testing of web application. That is more or less that we send HTTP messages to the application and check the output of those. And we do that automatically, almost like JUnit tests. So we do that to reduce the painful regression testing and reduce the time and effort of testing. That means that we can conduct testing more often. And that means also that we save resources and use computers for what computers are good for. And we use humans for what humans are good for. So a suggestion, not a requirement of assignment 2, is to write your manual test cases in such a way that you can automate them. Just to practice this. It's not a requirement per se, but I would say that someone who are looking for the A grade of that assignment, I would expect them to at least try to automate some of it. Perhaps not the start, stop, web server things, but I mean, that is not impossible to automate either. I mean, it's just some bash script or something like that. OK, and a good test suite is also easy to change when requirements change. If we have written, like I did, 10 tests on logging in, and then we remove or change the way that we log in. Suddenly we're using our thumbprints for logging in. And then I just need to throw out all those and write new test cases, right? So if there are tests that I can save from that change, that is a better test than a test that I need to throw out. Right? Agree on that? So if I have a test that can, for instance, adapt to changes more easily, like the test case I wrote 1.7, which used another test case as input, is actually quite good. Because if that test case changes, I only need to change the text in that test case and not all the others who depend on that. Okay, this is not super easy. It has to do with reducing the duplication of text and stuff like that. If I reduce the duplication, then I have less text to change. Yeah. It could also be to use some kind of software. I'm not really into that, but it could be to use some kind of software where you write your test cases not in a word processor, but in the software. I don't have any examples of that. Before, a couple of years ago, we had rational rows suite of tools for software development. Perhaps someone of you have heard about rational rows, and they have these test tools that I think could do that. Okay, quick to develop. We want them fast. We don't want to spend days and days to write these test cases, and that means that perhaps we're not using color pencils and writing small flowers around them. We just input them into the system. Perhaps we have things where we can copy paste from. Perhaps we have templates, stuff like that in order to do those. Quick to develop, and we can use these test cases during the development. So it's quite good if everyone can run these automated test suites while they're writing their code. Yeah, we want the test suite to be minimal, and it should give us enough confidence. It should not be redundant. It should not test the same thing over and over again unless there is a point with it. I mean, so these are like, it should have cover, it should find bugs, but we want it minimal. And I mean, these are orthogonal requirements for this, right? So we need someone who makes a judgment here, and that someone is you. So you don't have super much time for assignment 2, so you need to use that time wisely. And lastly, it's good if we can use the same test suite again to convince our customer that we're doing a good job. Or some part of the test suite could also be used for acceptance testing. So even if we automate these, perhaps we can also get a manual version of this so that we can put our customer and they can test the system and learn from this. Okay. Yeah, I think we need a break, so let's take a 10-minute breather. No. Okay, welcome back with audio. Okay, so we were talking about the best test suite, and I was saying that we want it to be minimal, but we wanted it to be thorough and find all the problems, but we don't want to spend much time producing it or using it and stuff like that. And I mean, this is not super easy, and in order to succeed, we need to do something called assumptions. And to curse a bit, I would say that assumptions is the mother of all fuck-ups. And that sort of means that when we assume something, that is often when we make mistakes. So in order to minimize work by assumptions, we want our assumptions to be informed. And one way of doing that could be to do things that are smart. Like if we're going to regression test something, then let's take a look on what was changed, and let's test only things that were changed. And let's not test things that were not changed. So if you have 1,000 manual test cases, then this can make huge difference if you only test test cases of the things that you actually changed, contrary to test everything. Okay. So other kind of assumptions that we can make is that we could think of the system like a black box. So the first example is going to be, and you've seen this one before, and black box testing was that we don't think about what's inside the box, and we generate test cases. And let's have an example again, the max example. In this case, we have 3 arguments. So we have A, B, and C, and the requirements is sort of stated up here. It should return the largest of the 3 inputs. It's a really stupid piece of code, and all inputs must be positive numbers, bigger or equal to 0, and it should throw exceptions on negative numbers. So if I were supposed to write test for this, I would have one test case where I create test data, where A is the biggest number, and B and C are numbers lower than A. For example, I have the sequence 3, 2, 1, or something like that. And then I would have a test case where B is the largest one. And I expect the B to be returned. So let's have 2, 3, 1. And then I would have a third test case where C is the largest one. And I would perhaps have 1, 2, 3 as test data or test input in order to get those 3. Because what I've done there is that I'm assuming that it does not matter if C is 3 or 4 or 5 as long as it's largest. That is my assumption. I would also, since if an input is a negative number, then we should throw an exception. So I would test that if A is negative, I would expect it to throw an exception. And if B is negative, I would expect it to throw an exception. And if C is negative, then I would create these. So I have like 6 test cases just from assumptions. And I'm assuming that a negative number of C doesn't matter if it's like -1 or -100. So I just create one test case for that. Yeah, sounds reasonable. Doesn't have to be, but... And what I'm sort of doing inside my head is something called equivalence partitioning. So equivalence partitioning is where we divide the input into equivalent disjoint subsets. Equivalent means that each number or each input in this acts the same according to the system, right? Disjoint means that not a single number exists in different subsets. So let's take an example. I have given you the Wikipedia link if you need to read up on this. I'll give you an example. So we have an add user method. It takes an age And we want age to be a valid number. So let's assume that this is the age of a person. So I would say that a negative number is an invalid input. So I put -5 up here. Unexpected invalid input is -5, while 0, 3, and 5 are all equivalent valid input. Then we could think about, what about really large numbers? Like, how old can someone be? If they must be alive, I mean, it depends on your viewpoint. You can look at statistics of human beings' age, and you can think about what is the population we're thinking about here. But I put 120 because I don't know much people over 120 that is supposed to be in this system. So I put 120 as the largest number. So I would say that valid ages are between 0 and 120. And I would say that negative numbers or larger numbers than 120, like 121, are unexpected invalid inputs. I just put these two partitions. We could have other partitions, and I'm going to show that in a minute. I just partition in valid and unexpected invalid, or invalid. We can partition in different ways. Okay. We talked about black box testing, and now we consider white box testing. So we're going to have an example where we think about equivalence partitioning, but take a look at the code. Because normally, we are not really here as developers. We are more or less here. So take a look at this code and try to do some equivalence partitioning on this. So we have a buffer. We check if the buffer contains line breaks. And if they contain line break, we take the position of the line break, and then we extract a substring of the buffer, which is the part of the string that was up until the line break. Sorry, we need to share the screen a bit better. Why? This is weird. This is a bit weird. Didn't really save the position of the... Okay, sorry. So I'm going to mess with this just for a moment. It's for the people here, they're not really seeing the screen anymore because the camera thing that I saved is gone. And that was too slow. So something like that, and then you can probably see the code. Yeah, thanks for letting me know. Yeah, so if we have a line break, then we take the substring of from the beginning of the string up until the line break, and including the line break, at least that is my belief. And we put that in the variable ret, and that is what we return later on. We also change the buffer so that we cut away the part that we returned, right? So we take the substring from that position and onwards and put that in buffer. So what are the equivalence partitioning for this? And at least me is not really thinking about equivalence partitioning when I'm testing this kind of code. It's sort of getting more or less sorry. Let's see if I can get the entire screen. Like that. I'm sort of, when doing black box thinking, it's pretty easy to do this, but when it comes to code, then it's often more messy to do this equivalence partitioning. We could have one equivalence partition where n or /n does not exist, and we could have one where it does exist, and then a third one where it does exist multiple times or you have a longer string, because you need to have different test cases for all of these. So it's the problem here is that the input is not easy. It's sort of hidden inside as member variables and stuff like that. But I'm sort of just want to show you that it's not always super simple to see these things. So let's go back to more easy examples again and talk about multiple partitions. So let's say that we have this example where we have a method called getLoan. So we're perhaps doing a bank application. And we're saying that we need to have, we only give loans to people that are old enough, 18 or more, or young enough, 65, and young enough, 65 or less. Because we don't want to give perhaps people who are going to die if we're a greedy insurance company or bank. Perhaps we think like that, because that's how greedy people think. And we also want to make sure that this person can return the loan. So let's say that we have another requirement that they should have at least 25,000 pounds a year in income. That's not super much, but it's at least you need some kind of income. So we have two variables as input. And I mean, this does not need to be code, really. It can be manual test cases also. So what we do is that we need to identify the input domain. And the input domain is two integers. So the size or the number of variation of the first integer times the number of variations of the second integer becomes too large to test, right? So we need to come up with good test cases. We divide the input domain into equivalence partitionings. So we say that all ages below 18 is too young. And then all ages between 18 and 65 is of age. And then we have a third part, which is 66 and larger is too old. And then we have, for the salary, we do the same. We say that if you earn less than 25,000 pounds, that is too little. And then you have enough. Or if you have 25,000 pounds or more, then you have enough. So we can divide it, and then we combine these. So you have too little, too old, but enough, and stuff like that. And then you get this kind of matrix because it's just two axes, but really this could be many axes. So for E5 is where we have people who are going to get loans, right? Because they are having an income, which is the x-axis, more than 25,000, and they are between 18 and 65 years old. And then we could create one test case for each of these 6 things. Right?
You could, but it's not needed.
It's not probably not needed, but I mean, programmers make mistakes. And I've at least seen one student who logged in people with only the username and not considering the password. So even stupid mistakes are made. Yeah. So we could argue that E1, E2, and E3 could be merged into just one test case. Sure. It's assumption we're using again, right? We're assuming that the programmers are doing something that is reasonable. Yeah. OK. On top of this, I want to give you boundary value analysis. And that is that we partition the input domain, and we've already done that. Then we identify the boundaries between these partitions. And we create test cases on the boundaries. So that would mean that we have a boundary here on the 25,000 pound. So you have 24,999 pounds and something like that. And then you have a test case where it's 25,000 pounds. So you create on both sides of the boundary. And on the same thing here on the age, you have one test case where someone is 17, and then you have another test case where they're 18, and then you have a test case where they're 65, and then you have a test case where they're 66. And then you can combine these, of course, so that for all of these edges you have all the cases. Yeah. That is sort of it. And so let's talk a little bit more about, it seems that students in VECO have not really started with assignment 2 yet so far. Some have read the assignment 2. Is that a correct assumption? So what about other people? I think that assignment 2 should be started this week. And we assume, or I assume, that to complete assignment 2, each student should put in 40 hours. And with 20 hours a week, because you're taking another course at the same time, that becomes 2 weeks of 20 hours, right? And you need to plan this time in order to do reasonable things. So I want to see the plan for assignment 2. And I just want you to take a look in the end of this assignment, because you're supposed to review each other's work. And then to make sure that people are reviewing sort of the same, I've written some instructions for that. And those instructions are actually the ways that your artifact is going to get judged. So read this carefully. And let's discuss this if you don't understand them. So ask questions in Slack on these things if you don't understand them. But reading this, you can come up with the conclusion that, okay, I need to think about my language. I need to have titles and different levels of titles. I need to write in a clear way so I can read it from top to bottom, and I don't need to jump super much in order to understand things. That is clarity. Then completeness is that it should have a test strategy, it should have a test plan, it should have manual test cases, and it should have a test report. And all of these should contain different things. And these are put here as questions, like, does the strategy describe the available resources? So it becomes, I think of this as a checklist that you should use in order to create these things, right? Perhaps you need other things also, and not just this. In the end, there are, I want to say something more about completeness. Completeness says that you need manual test cases. And that is, I think, I think that manual test cases is like the minimum thing. You should have manual test cases that cover the requirements given. But you could also do other things. And probably, if you want higher grades, you should do other things. You should try to do things that finds bugs, that finds problems. So the content here is a bit different. It says, has the other group done a good job testing of the product given the resources? So you consider their resources. Oh, they only write like 3 manual test cases for covering 3 use cases. That is probably not a good effort, right? Or did they do a really good effort? Perhaps they also automated stuff. Yeah, things like that. And you have done this assignment yourself. So when you review this, you're supposed to compare yourself a bit. Those did find a bug that I didn't find. That was probably good. I found like 3 bugs that they didn't consider, or did they not consider those as bugs at all? Things like that. Yeah. The deadline, when is that? The deadline is in the, all deadlines. Next week, Friday. They should be in the study guide, and they should be in the schedule, I hope. I try to be very clear with my deadlines. I hope I am. Yeah. Thank you. Part 1, December 14th, 1600. Okay, assignment 3 is a video presentation. It should be a short 5-minute video presentation of a peer-reviewed scientific article on testing. You should use one of these databases. There are other places to find papers also, but in order to get a peer-reviewed article, I would use one of these. There are actually articles in these that are not peer-reviewed also. So be a bit careful, check if there's a journal or a scientific conference that stands behind this article. And then check if it's peer-reviewed. So, and do that. And peer-reviewed is the process of scientific evaluations, really. So I write a scientific paper, and other scientists that I don't know is going to review my work and see if it's crap or good, more or less, and give me some feedback if it's crap. So that is the peer review process. And if you're uncertain on this, then contact Linnaeus University library staff. Go to the library. They're really good at this. They actually want you to go there. So use those people. I'm always getting a lot of sending me the article and is this okay? But really, I want you to check if this is okay. Is there a journal or conference? Is there a peer review process at this journal or conference? Check that out. Then you read this. And you read it probably not only once, but a couple of times. And then you try to extract important information. And I've written a couple of questions that should guide you to this. Not all questions are relevant for all papers. If you find that none of these questions are relevant for the paper that you have selected, then you should select another paper. Because if it's not relevant, then it's probably not a scientific paper. So the most papers are like this. We have a problem somewhere. So we describe the background of the problem. Then we describe some kind of solution or some kind of investigation that we conduct. That is called the method. And then we get a result from that, doing that method. And then we discuss the validity of this result. How, if we saw this, but how is that for other people from other countries? And what if we did this wrong? And things like that. They are criticizing their own work and they are thinking about how valid it is. There are different types of validity. I'm not going into depth into this. And then, do they solve the problem or not? Or what did they learn really? What should be done after this work? And lastly, I want something in this really short video presentation, something from you. What changed in you when you read this paper? What do you think of this? If you make claims, you should support those with evidence, of course. I read another article where they said something else. I think this is contrary or whatever. Or I really like this article. I believe it's something like that. Yeah. And you should create a 5-minute YouTube presentation. Most YouTube presentations are like some slides, a voice in background, right? And then, as a second part of this, you are supposed to review 2 other students' their videos. And you're going to look at their videos and you're going to listen to those, and then you're going to ask them some questions, right? And you do that on YouTube also. So open your YouTube video for comments. This is, yeah. Okay. Can you please walk us through assignment 2 like you just did for assignment 3? I think, didn't I do this in the last lecture? I think I did, right?
Pretty sure.
So I mean, assignment 2 is, first you do all this testing on stuff like planning and manual test cases, and then you run all the tests that you've done, and then you report the results. You write all these strategy documents and stuff like that. The second part is that you review at least 2 other students' work. If you review more than 2 other students' work, that is better, because your highest graded reviews are going to be used to grade you. So if you review like 5 people, I think there are like limits for different grades, and you get really good quality reviews on some of those, then you have a higher chance of getting a good grade. If you review 10 people, then you have even higher chance, right? So, and it's probably a good idea to review more than 2, because if you write a review that is not accepted by us, I mean me and the tutor instructors, then that review is going to be removed and then you fail because you don't have 2 reviews that are approved. So do a couple of reviews, do more than 2. And it's also good because then you also get more reviews on your own work, right? And then you get different viewpoints and stuff like that. But you need to read up on how to be a good reviewer in order to do this. And I mean, if the time from getting access to a test report or the test and completing the review is like 5 minutes, then you probably did not do a good job. Reviewing takes time, so spend time on this. Plan for spending time on this. I know it's can be considered boring, but at least you have done you've done testing of this product. Let's take a look at a couple other students doing testing of this project. Perhaps you can learn something. Perhaps they chose another strategy. Perhaps they found the same bugs as you. Perhaps they didn't. So let's find out. And at least 2016, we had pretty good results. And a lot of students liked the reviews they got. Like 20% got at least 1 review that was crap. But most students felt that after me and the tutor instructors that year were done with these reviews, they felt that it felt okay. I mean, perhaps we failed that other review. Perhaps they actually just found something that was bad with your report. Yeah. Yeah, it is what it is.
When is the deadline for assignment 3?
So let's take a look at the deadline. So here are the deadlines.
Oh, yeah.
So January 7th is the deadline for the video, and January 14th is the deadline for the reviews of. So watch 2 5-minute videos, write a question on each. not much. Are there no tutoring sessions this week? So I don't have any tutoring this week because I'm working with examinations. But I mean, you can still write questions in Slack, and you should answer each other's questions on Slack also. I mean, you have the same assignment too, so it's probably the same. When we do peer review, do we need to write test case? I think the person I'm reviewing don't consider that part. When you do peer review of another person's work, you don't need to write test cases yourself. But the person, I mean, in this assignment 2, you should write manual test cases. There should be manual test cases there. It's one part of the things that you should review. So it was listed in the things. So you need to read these review instructions really good in order to understand what you should review, right? And if you don't know how to review something or how to score another student, then let's put that question in Slack, right? So that you ask there and we come up with something and I can give you my point of viewing how I would have scored, right? Great. I'm not super happy about moving deadlines. We're 140 something students. You've got the deadlines in the beginning of the course. You should be able to plan for this. I know that people are taking other courses. There are a number of other courses that people are taking. It's hard to make a schedule match every single course that you're taking. So I'm probably the class with the more students, so let the other classes adapt to us instead. If you want me to write a personal letter to some teacher, I can do that. Move aside, here we come. Okay, thank you for today.